Okay, so we're discussing anycast addresses, and basically what is an anycast address is an IP address which is assigned to multiple devices. That one IPv6 address is assigned to multiple devices, and a packet sent to any of those addresses is routed to the nearest device having that address. So like I was explaining, kana munhu ari muHarare anoshandisawo server remuHarare. That allows someone to use server remuHarare. Routing is very much easier. Basically, that defines an anycast address and also gives an application where anycast IPv6 addresses are used. Okay, I think this is almost the same things that we were discussing, one-to-one, one-to-many. Then with anycast, you see, these devices, they have the same IP address, but depending the routing, kuti chafambisa sei, a device which is nearest, ndo inoita sei, receive a packet. A server, especially, which is nearest, receives that packet. You can send it all from PC iri kunoko. This one receives the packet. Okay, prefix length. Prefix length is represented in slash notation. It is used to indicate the network portion of the IPv6 address. The IPv6 prefix length can range from 0 to 128. The recommended is /64. Not, it is strongly recommended to use 64-bit interface ID for the most networks. This is because stateless address auto configuration uses 64 bits for the interface ID. We'll look at Slack later on. I think the important thing to get out of this is one, patakaita IPv4, we had the subnet mask, which was used to separate the network portion and the host portion. I think we also had the prefix length. You can remember down the chance /24, /25, /26. That was the prefix length. It was also used to identify the network portion and the host portion. With IPv6, we only have the prefix length. So /20 /64 is the one which is recommended for reasons which we are going to discuss more in detail pambera. But one of the reasons has something to do with this auto configuration. IPv6 addresses, they make use of the MAC address as the interface ID, the host portion. So making use of that MAC address means it will need to use 64 bits. Like I said, we'll discuss this later on. What to get out of this is we have the prefix length. The prefix length is used to separate the network portion and the host portion. Kuno IPv6, the network portion inonzi prefix, then the host portion inonzi the interface ID. So the prefix length is basically used to identify kuti network and the kube, host portion and the kube. And what is recommended and what you see during the course, yes and no, we are going to use /64. And because my addressing space is edakakura, you will not see subnetting that much. As anongwari pa /64. Akuna /24, 25, 26, 27, no, /64. Right, types of IPv6 unicast addresses. Unlike IPv4, that has only a single address, IPv6 typically have two: global unicast and link local address. So in IPv6, a host is assigned one IP. In IPv4, I mean, a host is assigned one IPv4 address. However, in IPv6, every host has two addresses. One, the GUA. This is similar to the public IPv4 address. They are globally unique internet routable addresses. So public IPv4 address with IPv4, if we had a network like this, IPv4 address ye PC iri muno inenge iri private. Then we have another one which is used outside inenge ya public via NAT. Right? So with IPv4 tantine private IP address yaishanda locally, right? Then kana takuda ku communicate with the internet, we need a public IP address via address translation. That was the process. With IPv6, one of the advantages, we don't have to use NAT. Why? Because we have two more addresses ku IPv6. One address ndo GUA, ndo yakafanana ne-public ish. Ndo yakafanana ne-public, which we can use. Ndo yakafanana ne-public, which we can use to communicate over the internet. The other one inonzi link local address, ndo yakadawo kufananawo nechi ne-private, which is used on a local link. So basically, that's the reason why tine two more IPv6 addresses. One inoshana locally on a local link, which is called the link local address, required for every IPv6 enabled device and used to communicate with other devices on the same local link. LLAs are not routable and are confined to a single link. So basically, ku IPv4 tine private ne public. But kunoku tine address translation, translator from private to public. Ku IPv6, device iri riri rinenge rine GUA ne LLA, two IP addresses. You see, if you go and practice configuration ema IPv6 addresses pa my PCs epa packet tracer, you will see this one is what you usually assign, and this one will be assigned automatically. So every GUA inofanira kunge LLA, two IPv6 addresses. Let's continue. Other types, excuse. Other type of addresses that we have. So we've discussed this one and this one. Global unicast, globally routable, link local, only used on the local link. Then we have loopback. I can explain it. Loopback, loopback, then a link local unicast, multicast, RPS. Unspecified. Okay, RPS up. So let me leave this one. Let's continue, panel. Special IPv6 addresses. We have an address in the default static route. Default static route is an IP address which is used by a router to send packets when it does not have a specific route configured on the network. So for example, especially if you want to connect to the internet, there is what we call a default static route. Let me give an example. This one is very important, this type of route. In IPv4, this is the IP address, your default static route, 000. So basically, what does it mean? Let's say we have a network. This is the internet. So this is the internet. This is our LAN, right? My devices they can communicate with each other easily. So for example, let's say in the .100 IP address irimlanu. ndine .101, ndine .102, ndine .103. If I want to communicate with the 101, device A, then my destination IP address inoiswa 101. If I want to communicate with 102, destination IP address inoiswa 102. Ndikauya munetwork ndoisa .120 isimo munetwork. What will happen to this packet rina .120? Packet iroro rinotenderera munetwork richitsvaga destination which it will never find. Right. So packet kana risina kwekuenda munetwork, if you have a default static route configured parouter yako which is 0 0 0, ndokunoita sei? Ndokunoendeswa packet. Packet rashaya kwekuenda munetwork rinoendeswa kudefault static route. So usually default static route rinenge rakaiswa so that it leads kuma networks akaita the internet. Then rikaenda muinternet rinotenderera riri muinternet up until rawana destination. So the default static route is very important to configure on your network. It means mapackets haramba achitenderera munetwork asina destination. Packet rikashaya destination mulan rinoenda kudefault static route rinobudiswa roenda unotenderera riri elsewhere. Basically that is what a default static route is. Right, toenda pa unspecified address and is initially assigned to a host when it first resolves its link local address. I don't think we had an unspecified address to IPv4, but basically in IPv6, an unspecified address, it basically represents the absence of an address. Panotanga kupinda a device network, inenge isina address. It is assigned this address here, the unspecified address, meaning haisati yani address. Then pachaitika process yeSlack, for example, or parichazokommunicata neDHCP version 6 server, ndo painozopiwa address yayo. But initially inotanga inonzi unspecified address, and there is the address there. Then we talk of the loopback. Very important. You definitely get a question inobvunza something chinoenderana neloopback. Loopback address of localhost equivalent to 127.0.0.1 in IPv4. So this was the representation loopback for IPv4. What's the reason of having a loopback address? So a loopback address is basically assigned to a visual interface. It is not assigned to a physical interface, but router. It is assigned to a virtual interface, and it is used by a device to send traffic to itself. So if I have a router here, I create a virtual interface on this router. Then I send a packet to this address. If I send a packet to this address, then that packet rikudzoka papi? Parouter ipapo. What's the reason of sending an IP, a packet to yourself as a device? The reason is to test functionality of the device. So ndikazvisendera IP, ndikazvisendera packet, ndikakwanisa kuri receiver, it means I'm functional basically. It means the hardware of the device and the software, the TCP or operational suite of the device is functional. That's the main reason why we have yet not loopback. It allows my devices to send packets to itself so that they can test the functionality of the software, the hardware, and TCP of the device. I'm thinking of something very important for loopback. Loopback, in among my functions, for example, OSPF, you see it will be used by identify my routers in a network. That's another function. But the main one that you need to know, ukabvunzwa what is a loopback, loopback interface. What is a loopback interface, or what is a loopback address? So a loopback interface is the interface that is assigned to the device. Then the address is used to send a package to itself. It's like looking at the mirror basically. Kutarisa pamira. Ukatarisa pamira ukazviona, it means mirror riri functional here. It means kuzviona uri kuona kuti inini ndiri functional, ndakanaka sei uri pamira. But ukasazviona pamira, it means something is wrong. Ndo zvinoshanda loopback interface. Take the loopback interface as a mirror basically. Right, we have link local unicast addresses. So aya tambotaura nezvawo LLAs tataura nezvawo. They are basically used to communicate on a local link. And representation awo yese muchaona anotanga nani? Anotanga na FE80. So pese pamaonera FE80, that is a link local address. It is similar to the window auto configuration IP address of 169.254. I say APIPA auto configuration IP address. Leave this one here. Right, link local addresses FE80, very important. Pese pamona FE80, that's a link local address. Then multicast addresses, they have a range FF02, FF00, I mean, /8. The most common ones, FF that I know, 02. Then is O not E, that is a multicast address. This is the broadcast equal IPv6. So FF02 :1, that is an O node multicast address, which basically sends a packet to all the devices on a local link. No broadcast sekunoki. Kana unoda send a broadcast, you address it to FF02 :1. It's part of FF00/8. That is just one type of a multicast address. Then all other addresses, they're global unicast, blah, blah, blah. Reserved IPv6 multicast. Right, so I know my multicaster. FF00/8. So we have the O node, right, which sends to all devices on a local link. Then we have the all routers on a link. So basically this one, very useful kuma dynamic routing protocols. So for example, you have this router, inenwe router Apple, let's say in a 3 routers like this. So this central router is connected to 3 routers. If it wants to share information, or if it wants to get information from the other routers, it sends a packet destined to FF022. Then only routers will receive a packet in a destination yakadai. My devices M network for example, I got receive a packet here. They can't receive that packet basically, because that multicast address is specifically for routers. And that's the reason why multicast is more efficient than broadcast. Imagine with IPv4, how will you communicate with my routers? Because you can't send a broadcast to do that. How will you communicate? With IPv6, it simplifies that. There is a specific multicast address which only sends to routers. This one only sends to addresses on a local link. So you send a LAN ish. You send to all routers connected to router send that information. Then we have another one here. All routing information, RIP. That's another protocol that is used for routing. Only RIP. inoshandisawo ine multicast address yayo. So if a router is enabled to be using RIP, and if you use this destination, then information inosvikeko. Then we have the all solicited node multicast used for host auto configuration and neighbor discovery, similar to ARP in IPv4. So with this one, we talked about neighbor solicitation, NS. We also talked about router solicitation. So neighbor solicitation, to solicit is to ask for something. Neighbor solicitation, if you remember very well, but I discuss, a device was asking for something. I think it was asking who has this IP address. That was neighbor solicitation. Then you need a response. NA, neighbor advertisement. That response is destined to what devices? So let's say in a network, you have multiple devices that have sent RS, router solicitation. For example, right here, my routers they are going to send my RS so that they are requesting information about what is the routing status per network yedu. Panosendwa ma-RS from all these devices, device mangana E3. Panosvika panapa, RA response inosendwa apa. It should be a solicited multicast. Solicited multicast in the sense yekuti kwese kwasendwa RS, response inosvika. But kana irinori, for example, dai risinosenda RS, response haisvike because they did not ask for information. I don't know if I'm making myself clear, but I hope so. Because it's very important differentiating yet not solicited node iro multicast address ne o node multicast address. With RS, with a solicited node, only the device which has solicited will receive a packet, a response. Kana usinoita solicit, then you won't respond. There's no response which comes to you. It's the same applies Milan, for example. If I have 1, 2, 3, if this one sends